Hello, everyone. We're going to go over foundation science today. So, in class, we worked on our study sheets, and hopefully, you were able to finish your study sheet on your own. Look up your answers in your foundation science workbooks, and complete those study sheets. If you haven't, that's okay. We're going to go over it today. We're going to make sure that you've got the correct answers to study for the exam. Okay, so please follow along with me. So give me some patience. You're going to need some patience for this because I'm a little rusty on this, but I'm going to share my screen with you so that we can go through the questions together. You can see what I'm talking about, which one I mean. And we're going to try to watch some videos too. They're not working so well, but I'm going to give it a shot and see if we can get them working. Okay, but this just takes a minute for the slideshow to kick in. Oh, that seems to have kicked us out altogether. I don't know what's going on there. Let's see if I can try this again. Okay, sorry guys, technical difficulties. Hang in there. I don't know what's going on here. I don't know why it keeps kicking me out. Okay, bear with me. I will get this sorted out. Why is this not working? Trying to share my slides with you so that you can follow along on your Google Classroom, your study sheet with me, okay? Okay, so you can see my sheets. Now I'm trying to turn on the slideshow. And for some reason, that seems to be kicking us out. Why is that kicking us out of the sharing mode? Oh, I think it worked. There we go. Okay, finally. Third try's a charm. All right, so foundation science study sheets. We're going to go over them. So first thing we looked at global winds. Now I have a really nice video that explains them very well, but unfortunately I've tried doing that video many times and it takes too long. So I'm going to skip it for this one. I'm going to try the other videos. Hopefully they're shorter. Maybe they don't take as much bandwidth. But yeah, hopefully we can look at those ones. But let's go over our global wins. Okay, so the instructions are always important. So in your exam, always read the instructions and make sure that you are following them because you're going to lose marks if you don't read the instructions or if you give an answer that isn't what is being asked of the question, okay? So this one's simple. It just simply says label the, and that means to put all of those words onto your diagram, okay? Those become your labels. So where do we find trade winds? Okay, trade winds. Okay, trade winds are found between the equator and 30 degrees north and south latitude. Okay, so your trade winds are found in the northern hemisphere and the southern hemisphere on each side of the equator. So try to remember that, okay? The next one says polar easterlies. Okay, so the word polar, everyone should know what that means, right? So you're talking about the ends, so the southernmost point and the northernmost point on the Earth. So polar easterlies are up at the top of the Earth and on the bottom of the Earth, okay? Now, where would we find the doldrums? And what are the doldrums? Okay, the last two things we talked about, the trade winds and the polar easterlies, those are winds. Okay, doldrums are not winds. Why is this an important area for us to understand on our map? Okay, doldrums are areas that have very little wind. Okay, so when sailors were using the trade winds to go across to other continents to trade goods with other countries, they would use the trade winds. But when they got to the equator, they noticed that there was such a dead slack. There was no winds in these areas, or very little winds. Okay, so it took them a long time to pass the equator to get through the doldrums. Okay, so the doldrums are at the equator, and it's an area of very little wind. Okay, westerlies are another type of global wind. Okay, westerlies are named from where they start, blowing. So they start in the west and they blow to the east. So the westerlies are found between 30 degrees north and 60 degrees north, and 30 degrees south and 60 degrees south latitudes. Okay, so now we've got all of our global winds. We want to now label the horse latitudes north and horse latitudes south. Okay, so just like the doldrums, the horse latitudes are areas of very little wind. So where do we find horse latitudes north? Okay, think about that for a minute. Okay, so horse latitudes north are along the 30 degrees north latitude. Okay, and the same thing happens in the southern hemisphere. You've got the horse latitudes south. Again, areas of very little wind. Okay, so now we've done the first labels. Now we need to do the different degrees of latitude. So where do we find 30 degrees north latitude? Okay, try and figure it out. You know where the equator is. So then try to figure out 30 degrees north latitude. Okay, there's 30 degrees north latitude. And so where would 30 degrees south latitude be? Okay, again, the equator will be in between both of these. Okay, there's your 30 degrees south latitude. Okay, 60 degrees north latitude. Okay, up on the top of your screen, and 60 degrees south latitude, again, on the bottom. Okay, and the equator right in the middle, where your doldrums are. Okay, so all of you should be very confident where these winds are, where the patches of no wind are, and where the latitudes are. You will be asked to label these on your exam. So please make sure you understand these and know where they are. Okay? All right, moving on. Now, we talked about the global those were global winds. Now we're going to talk about local winds. And there are 4 different local winds that we talk about. Okay, so there is a little video that is a short video. So I'm hoping we're going to have a little more, luck with seeing this video. So I'm going to give this a try, guys. Okay, bear with me. Let's see if we can figure this out. Oh, wait a second here. Oh, that's weird. They're out of order. Okay, let's just do this again here. Yeah, there they are. Okay. Okay. So how do I go to there now? Oh, maybe I do this. Okay, hopefully you're still seeing what I'm seeing. Okay, there you go. Sorry, it took me a minute to get that. Okay,
What causes these winds to blow? Wind is caused by unequal heating of our atmosphere. In this video, I'd like to show you examples of local winds like these sea and land breezes and these mountain and valley breezes. Welcome to Moo Moo Math.
Uh-oh. I'm also trying to turn it up for you because it seems to be quite low. Okay. No, this one's not working either. Okay, maybe I will make it smaller. Maybe that will help.
And local winds. And sea breezes are considered local winds because they only travel a short distance. But what causes them? Like other winds, these local winds are a result of unequal heating of our atmosphere. Land and water warm up and cool off at different rates. This statement will help you understand land and sea breezes. It is, land always wins. What this means is that land
We lost it again. Okay, hang in there. Oh, I don't know what's going on with these videos. It's too bad because these guys describe it so nicely. I can describe it for you again, but it's nice to have somebody say it just slightly different so that maybe something clicks, right? Something, it just becomes easier to understand. Okay, well, we're going to have to abort that, unfortunately. Okay, let's see if we can go back to the other one. Okay, let's go back to our slideshow. And hopefully... Okay. So back in the slideshow here, let's go through this since the video is not working, unfortunately. So over here, hopefully you can see the arrows. Yeah, you can a little bit. Okay. So during the daytime, we have a sea breeze. Okay. The sun is out. The sun is heating up the land and the water. Okay. Because both land and water have different specific heats, that's a characteristic of them. It simply means that because they're different, that the land heats up at a different rate than the water heats up. Water has a higher specific heat, so it takes longer to heat up, but it also takes longer for it to cool down as well. Now, during the daytime, the land warms up quicker than the water does. So we've got a low pressure over the land. Okay, so when air gets heated, it wants to move apart, thermal expansion, and then it also wants to rise up. So that's called a low pressure air. So because this air wants to rise, the low pressure is going to go up and the high pressure is going to come in behind it from the water to the land. So that's why this is called a sea breeze, because all winds are named from where they start. This breeze starts over the sea, goes towards the land. We call it a sea breeze. So at nighttime, we've got the opposite thing happening. So let's understand what's happening at night. So at nighttime, instead of the land being warmer, now the water is warmer. Now you've got low pressure rising up over the water. It's heating the air above it, and that warm air above the water now wants to rise into the atmosphere. So then what has to happen is there has to be high pressure air coming in to fill the place. High pressure air is colder, it's more dense, it's more compact. Okay. And because this is now a land breeze, it's going to start in the land and move towards the water. Okay, and then we just draw the other arrows on there to show that this whole thing is one big convection cell. Okay, and we'll call this, we have to label this as a land breeze because the high pressure wind comes from the land to the water as the low pressure is moving above the water because it's warmer at this point. Okay, so before we did that, we should have read the instructions to see what we're supposed to do. Draw arrows to show the wind direction. Okay, we've done that. Okay, the next one is draw 2 arrows on each diagram to show wind direction and name each one of these local winds as well. Okay, so in the first one, the sun is shining. And do we remember if this is a land breeze or a mountain breeze? You don't necessarily have to know, but it is a good idea to remember which one is which. But we can figure this out. Okay, so the sun is shining. The sun will be warming the air around the mountain tops, around the mountain slopes, okay? So all of the sun is now hitting the tops and sides of these mountains, and that is warming up the areas. So there is low pressure moving up from the tops of the mountains. So when that low pressure air is moving out of the way, it means the high pressure air has to come in behind it and fill up the space. So that air comes from the valley. So the valley has cooler air, and the cooler air now goes up the mountain to the mountain tops and the sides of the mountain tops where the air is warmer and is moving up into the atmosphere. Okay, so that's happening from both sides. So cooler valley air is moving to replace the warmer mountain air that's now moved out of the way. So the air from the valley to the mountain is a high pressure air. Okay, air, when it moves as winds, it always moves from high pressure to low pressure. Okay, so don't forget that. That's a good one. All right, and we name this one, this is a valley breeze because the breeze starts in the valley and goes to the mountains. Okay, so at nighttime, we've got the opposite thing happening. So now we know, since the daytime is a valley breeze, we know the nighttime is a mountain breeze. So let's think about this. At nighttime, the sun is no longer warming the tops of the mountains. So now there is more warm air that has settled in the bottom of the valley than there is on the tops of the mountains. So the warm air from the valley is now rising up, and now the cooler air from the mountaintops has to go in and replace that warm air as it rises. Okay, so now we've got cooler, high pressure air coming from the mountains down into the valley because the valley has the warmer temperature now, and that low pressure air is now moving up towards the atmosphere from the valley. Okay, so cooler, high pressure air has to come in and replace it. All right, so I hope you don't have any questions about that, because I'm sorry I can't answer them right now, but you can always ask me in class. I will go over this with you as many times as it takes to remember this, okay? All right, moving on. Oh, sorry, that's a mountain breeze. All right, here we go. Okay, so when we talk about weather, there are many different elements of weather. And with each of those elements, we measure them in a different way. We can't use the same instrument to measure all the different elements of weather. That's just not possible. Because each element is so different, we have to use a different instrument. So we are to fill in the blanks with the instrument used to measure each element of weather. So if you want to measure temperature, you use a thermometer, okay? We've used thermometers in the laboratory, so I hope you guys remember that, and that's an easy one for you guys. You won't get a mistake on that one, okay? So the first one, if we want to measure temperature, we use a thermometer. Okay, if we want to measure relative humidity, what do we use? Okay, I'm giving you a minute to think about this. If you want to measure relative humidity, we use something that looks very similar to a thermometer, but it's not a thermometer. It's got a different name to it. What do we use? Okay, we use something called a psychrometer. Okay, a psychrometer. And when we want to measure precipitation, first of all, what is precipitation? What is precipitation? Okay, think about that. Precipitation is all of the water that falls from the clouds and lands on the earth. Okay, now it's water, but is it always in liquid form? Is it always as rain? No. We can also have snow and sleet and hail. Those are all frozen forms of precipitation. But when it comes to measuring rain, we use a simple, very simple instrument. It looks a lot like the graduated cylinders we used when we were trying to discover the volume. We were using water displacement to find the volume of irregular objects that we couldn't measure. Okay, so it looks a lot like a graduated cylinder, and that's all it is. The water falls in the top, and you go out and you make sure you understand, okay, it's been 3 hours now, so we'll go and measure the amount of rain. It's been 6 hours, it's been 24 hours. You know, you have to make sure that you state the time interval in which you are measuring the rain, and then you're able to use this instrument to measure rain. So we measure precipitation, specifically rain, with a thing called a rain gauge. Okay, a gauge is simply any device used to give us a reading on something. Okay. All right, the next one is air pressure. What do we measure air pressure with? You might even be able to see it on this instrument in this picture if you look really closely. Okay, what is this thing? All right, this type of instrument is called a barometer. Okay, a barometer is used to measure air pressure. It's able to measure the force at which the air molecules are pushing on the earth at a specific spot, okay, at a very, very specific place. Okay, now barometers are interesting because the amount of air pressure can indicate whether it's going to be sunny or rainy, depending on what the readings are. So I think that's quite interesting. On this barometer, it looks like if you've got a low, yeah, the lower the reading, the more rain you get. The higher the air pressure, the sunnier you're going to have. More sun. Okay? Okay, the next one, wind speed. This funny little thing, it measures wind speed. What is its name? What do we call this instrument? Okay, what do we call that instrument? That's an anemometer. Okay, anemometer. Lots of syllables in that one, okay? Anemometer. And it rotates, it goes around, okay? And it measures how fast the speed is how fast the wind is blowing. All right, and the last one is the wind direction. Okay, we've got our little chicken on a stick, and he points in the direction of the wind. What do we call these little things? We don't call them chickens. If you put chicken on it, you won't get a point. Sorry, guys. You have to call it a weather vane or a wind vane. Okay? It's a wind vane is the name of that one. All right, so make sure that you know these for the exam because these will be on there as fill in the blanks. If you don't know how to spell, like a psychrometer or an anemometer or barometer, if you don't know how to spell them the best you can, as long as I understand what you mean. What you can do too is in the exam, go and look in the multiple choice questions because a lot of times I will put those words in your multiple choice so that you could find the spelling of them, okay? So please don't forget to do that. All right, moving on. We've got the steps in cloud formation now. Okay, so if you look at the little picture, you see the sunshine, you see the water vapor. Okay, so these are steps in cloud formation. So the first step is the sun. Okay, the sun has to come out, or it doesn't even have to be out. I mean, the weather just has to be warm enough to heat up the water. Okay, so the sun, sorry, just a second here. The sun heats up water. Okay, so the top layer of the ocean or the river, or well, not the river so much, but more like the pond or the lake, the top layer gets heated up by the sun. And as that water starts to heat, what does it start to do? Okay, when you heat water up, what does water do? What is the change of state that happens? Okay, so for number 2, what is that change of state that happens when you heat water? Okay, water evaporates. It changes state. It goes from a liquid to a gas. Okay, so water evaporates and fills the atmosphere with water vapor. The water vapor is warm air and warm water. So what happens when air gets warmed? What does it want to do? Okay, when you heat air, the air particles will then start to move away from each other because they gain energy. They gain a lot of energy and they want to move around further away from each other. Okay, and by doing that, it also makes it less dense. So it wants it wants to rise up. Okay, so the warm air and water vapor, they start to rise. They start to go higher into the atmosphere. It keeps rising until it gets high enough that it starts to cool. Okay, and when we cool water vapor in the air, what happens? Again, now this is a change of state that happens. It's the change of state that's opposite to evaporation. We did a lab with this in the summertime. We had soda. We took some Coca-Cola. Lots of you guys liked your Coca-Cola. And we put it in a plastic cup. And then we did an observation of that plastic cup to see if anything was happening. When I put the soda in the cup, does anything happen? No. When you put the ice cube in the cup, what happens? Okay, we started to see condensation happen on the outside of the cup. That's the same thing that's happening up in the atmosphere. When that warm air and water vapor rises up in the atmosphere, it starts to get to a point where it starts to cool off. It starts to get really cool up there. And it cools to a special point called the dew point. Okay, so it's in vapor form, but it's up so high and it starts to cool. It hits this special dew point, and at the dew point, that's when condensation starts to take place. Condensation is when you change from a gas back to a liquid. Okay, that is the opposite of evaporation. So the evaporation and condensation are opposite changes of state. Okay, so number 5, condensation takes place on tiny solid particles like smoke, dust, air pollution, and we could just go on and on and on. There's all kinds of things floating around in the air. But condensation can't just happen out of nothing. It has to find a little speck of something to adhere to, because that little tiny water droplet needs to hang on to something out in the atmosphere. Okay. Now, if you look at the little diagram on the bottom below the writing here, you'll see you've got water vapor and you've got dust. Now, when the water vapor sticks to the dust, it's now called a water drop. And then when you have lots of little water drops together, you form a cloud droplet. And when you have lots of cloud droplets together, that's when you form a cloud. So number 6, 7, and 8 is going through that cycle, that step, okay? So number 6, something form on small particles. So you've got water drops form on small particles. Then it says many water drops form a, right? So follow the diagram. If you've got many water droplets, they form a cloud droplet. Okay, and many cloud droplets together form a cloud. Excellent. Okay, so please understand the steps in cloud formation. I believe there are multiple choice questions about that on the exam. There might even be 1 or 2 fill in the blanks. So understand how this happens. Understand how we need to have evaporation first. All of the water vapor has to first go into the atmosphere. And then when it starts to condense out of the atmosphere, while still in the atmosphere, that forms a cloud. That's how clouds are made in the sky. Okay, now we'll talk about clouds. And again, I'm sorry that the photocopy on your study sheet did not turn out that great. So please look at this picture of the clouds and follow along with me. So now you can see where A is. A is one of those very high wispy clouds. Okay, so please memorize the clouds that are the white clouds on this thing. You need to memorize where they are, what they're made of, and things about. Okay, so A, very high altitude cloud. It is so high altitude that it isn't even made of water droplets. It's made of ice crystals. Okay, it is so high up in the atmosphere, it's made of ice crystals. So it is usually never a rain cloud. Okay, you will never see nimbus with this type of cloud because nimbus means rain. Okay, but this type of cloud is never a rain cloud because it's so high in the atmosphere. So this cloud is called a cirrus cloud. And you have to remember that, okay? Cirrus are the very high wispy clouds made of ice particles, no precipitation, okay? Now B. B is one of those very tall, scary looking, intimidating clouds. Okay, this cloud brings all kinds of lightning, thunder, very heavy rains, very high winds. Sometimes you can get all kinds of like hurricane, tornado type weather with this. They bring really bad weather. Okay, and this cloud is called, and you have to again memorize this. This is a cumulonimbus. Nimbus is in the word of this cloud, so it means it is a rain cloud. It's a type of rain cloud. Okay, C is a smaller version of a rain cloud because it's gray. So if a cloud is white, it's not a rain cloud. If it's gray or dark gray, it's a rain cloud. Okay, C is another type of rain cloud, but this rain cloud is very small. It's in a layer. It's close to the Earth's surface. So those type of clouds are called nimbostratus. Okay, remember, stratus clouds are low-level clouds close to the Earth, and they'll always be in a layer. Okay, D. Aha, speaking of that, these are your stratus clouds. Okay, so these are normal stratus clouds with no rain. They are layers, they are close to the Earth, And if you have a stratus cloud that is on the surface of the earth, that's called fog. Okay, that's where fog comes from. All right, so how about E? E is one of those big fluffy clouds. You just want to take a bite out of it. It looks like cotton candy. Okay, which one is E? E is your cumulus. Okay, cumulus clouds. And the next one says the prefix cirro means. Okay, so when you see this prefix cirro, which cloud does it most closely resemble? Cirrus. Okay, and you have to remember cirrus clouds are found very high in the atmosphere. So cirro means high clouds. Okay, those are the clouds you'll find very high in the atmosphere, made of ice crystals. Okay, and as we talked of just a little bit before, nimbus. Nimbus means, look at where we see nimbus here. We see cumulonimbus and we see nimbostratus. Okay, both of those clouds are rain clouds. So nimbus means rain. Okay, remember those words. You'll need to know those. Okay, here we go. So, all right, so this is what you guys all hate to fill in, but honestly, this doesn't take that long to do. It's just a couple words here and there, and there's a couple definitions that you should write down. Okay, when it comes to wind, I don't know how many students forget the definition of wind. Okay, so wind is air that moves horizontal to the ground, so it moves along the ground. Okay, and wind is caused by differences in air pressure. That is the definition of a wind, difference in air pressure. You've got high pressure, low pressure. High is always moving towards low. That is a wind. That's how winds form. Okay? Cause of wind, uneven heating of landforms. Land and water have different what? What is the special scientific term of why land and water heat up at different rates? Why do they heat up at different rates? Okay? It's because they have different specific heats. Okay? Water has a very high specific heat. It takes a longer time to heat up and a longer time to cool down. Land has a very low specific heat. It heats up quickly, but it also cools off quickly. Okay? Land warms up faster and cools off faster than water because, okay, its specific heat is lower than that of water's. Okay, please write these down if you don't have them, because writing it down will help you to remember it, okay? It's been studied and shows that this actually helps you to remember things by writing them down. Typing them doesn't help. Writing them, yes. Okay? Winds are named by the direction. What do you think? Winds are named by the direction from which they blow. Okay? This is a weird way of saying winds are named by the direction from where they start. Okay? If a wind starts in the west, it's going to be named after the west. Okay? It's a westerly or something like that. Okay? So if it starts over the land, it's going to be a land breeze. All right? Winds are named by the direction from which they blow. So in other words, from where they start. Air moves from areas of blank pressure to areas of blank pressure. Okay? Remember this always, from high pressure to areas of low pressure. Okay? High pressure is cooler air. It's high pressure because it's higher density. It's more compacted. It's squeezed together. Okay? Low pressure is very it's warm weather because it's expanding. It's moving away from itself. You know, the particles are moving away from themselves. It's a lower density air. So it's low pressure. So you'll always get the cooler winds, cooler breezes coming in to replace that air that's moving up in the atmosphere, the low pressure air. So always from high pressure to low pressure. Okay, well, how do we describe a global wind? How do we describe a global wind? Okay, we looked at the trade winds, the westerlies, the polar easterlies. Those are our global winds. How do we describe those? Okay, wind systems near the Earth's surface around the world. Okay, it's that simple. Global meaning world, around the world. And they're just wind systems that are close to the Earth's surface that are around the world. Okay, local winds, same idea, but this time movement of air over short distances. We're talking about just in the area where the land and the ocean meet, or just in the area over where the mountains and the valleys are. Okay, so now this is where it gets kind of tricky, and you got to think about this. So a sea breeze. Sea breeze happens during the, do you guys know what time when it happens? Okay, during the day. Okay, and because it's a sea breeze, the wind blows from the sea to the land. Okay, now during the day, the sun heats up the land. The land, think about it, you know, when you're trying to walk on that hot sandy beach, how much your feet are burning because the land is so much hotter than the water. So, you know, you jump in the water to cool off your feet. You can think of it that way, right? The land heats up quicker. So that low pressure air rises above that, and the cooler air comes from the sea and goes to the land. All right, so the opposite happens at nighttime. So the land breeze happens at night. Wind blows from the land to the sea. Again, it's a land breeze, so it has to be named from where it starts. Valley breeze. Okay, do you guys see a pattern forming here? Okay, valley breeze happens daytime, and a valley breeze blows from the valley to the mountain. Good. Okay. Again, mountain breeze. We got to flip it all around, same as we do for the sea breeze and the land breeze. Mountain breeze happens at the nighttime. Wind blows from the mountains to the valleys. Okay, because we've got different heating of those different areas. All right. Okay, the Coriolis effect. Oh boy, that's a big name. Okay, I will not expect you to be able to spell that. If you are having to put that into a blank or anything like that, look in your multiple choice questions. I know 100% sure that there is a multiple choice question with Coriolis written in it. Okay, so the Coriolis effect. What is that? What is that? Do you guys remember? Okay, Coriolis effect. So on all of the pictures that we look at of the winds, they're always curving. Okay, the winds don't blow in straight lines up and down, north to south. They blow kind of from west to east or from east to west. Okay, and they're always curved. So the Coriolis effect is the curving of this wind because the Earth is rotating. Okay, so the cause of the Coriolis effect is the Earth's rotation. It has nothing to do with the sun, the moon, the stars, the galaxies, nothing like that. Those winds are curved because the Earth is rotating. Now, if the Earth stopped rotating, those winds would blow from north to south or south to north. They would go in a straight line. Okay, but because the Earth is rotating, they kind of bend these winds. Okay, kind of a neat effect. All right, and the next one is jet stream. Okay, I told you guys about my plans for going to Canada to see my mom. When I fly to Canada, So when I fly to Canada, I'm going from the west to the east, and the time to fly directly to Vancouver is so from Bangkok to Vancouver is about 13 and a half hours, I think. But when I come home, it's closer to 16 hours on the plane. Wow. Why are those direct flights so different? Because of this thing called the jet stream. Okay. The jet stream is narrow belts of very high speed winds blowing from the west to the east. The pilots know where to find these jet streams. You can even see kind of like clouds that are in a line up in that area. So I think the pilots are able to find these jet streams. And when they do, if they're going with the jet stream, it kind of pushes the plane onto your destination very quick. But if you're going against the jet streams, and unfortunately on the way home, yeah, I go against the jet stream, it makes my trip a lot longer. But yeah, jet streams, they're very interesting, very, very interesting weather phenomenon. Okay, so speaking of weather, what is weather? How do we describe weather? Okay, is it what's happening all over the world? No, that's more climate. Okay, when we talk about weather patterns on a global scale, we're talking about climate. Okay, now weather is very specific. We talk about the weather in Bangkok. We can even talk about the weather in Bangkok. Like we can be that specific because even a big city like Bangkok can have different weather happening in different areas of the city. So weather, the condition of Earth's atmosphere at a certain time and a certain place. It's very specific. And this weather changes very quickly. Excuse me. On the other hand, climate doesn't change very quickly, but weather does. Okay, weather is in a very specific time, specific place. Okay. How would we describe visibility? Okay, visibility. When I think of visibility, I think of what is the pollution today? I look out the window, and if I can't see that big high rise beside us, I know we've got some problems, right? So, how do we describe visibility? Okay, the official term is the measurement of the transparency of the atmosphere. So, transparency, can you see through it? Okay, so visibility is how far can you see? The visibility today is beautiful. It does not look like there is much pollution in Bangkok today at all. So visibility is very good today. All right, moving on to another element of weather, humidity. Humidity. Bangkok is notorious for having very high humidity in the summertime. What is humidity? Okay, simply put, the amount of water vapor in the air. Okay, humidity, how much water is in the air? And it'd be hard if somebody said, oh, 3 millimeters or whatever. It would mean nothing to us. So we use another term called relative humidity. It's the same definition as humidity, but it is then stated in percentage. Okay? So in Bangkok, we can say, oh my gosh, it was so humid. We had probably 80% humidity today, 90% humidity. Okay? That's a lot. That's when you feel the air is very wet. Okay? And so relative humidity is when we talk about the percentage of water in the air. Okay. Next one, dew point. So dew point, very special point. Okay, the dew point, temperature at which more condensation than evaporation occurs. Okay, this is when the temperature drops low enough that condensation now wants to happen. Okay, so the air can evaporate, water vapor can evaporate into the air and keep going, but as the relative humidity gets higher and higher and higher, There's only a certain amount. You can only get 100% relative humidity before condensation starts to happen, okay? So the air will then cool to the dew point. When the air goes below the dew point, condensation starts to happen. Okay, fog. How do we describe fog? Fog is simply a low cloud. It's a type of stratus cloud that is near the Earth's surface. Okay, a very low cloud. Yeah, that one's easy. Okay, and air pressure. Okay, how do we describe air pressure? Think of pressure. You know, pressure is pushing in on something. You've got lots of pressure. Okay, air pressure is the force of air molecules pushing on an area. So, the air pressure at sea level, where we live, is going to be much greater because there are more air molecules right now than if we go up the side of a mountain. Okay, as we go higher up the mountain, the higher the altitude, the fewer air molecules. So the smaller the air pressure. The air pressure decreases as we go higher up. So that's the answer to the next question. As altitude increases, as you climb up the side of the mountain, air pressure decreases, it goes down. And why does air pressure go down? Because there are fewer air molecules at higher altitudes. So don't mistake the fact that the concentration of air that we breathe is the same concentration up at altitude. It's just that there are way fewer molecules than there are down at sea level. Okay? All right. We're almost done. This is it. Last page, guys. Here we go. Precipitation. What is precipitation? Okay, again, I don't have a jazzy little way to remember this. Precipitation, any form of water that falls from the sky, okay? So water that falls to the Earth's surface from the clouds, okay? Clouds make precipitation. And that's simple as that, okay? They make rain. So what state of matter is rain? Okay, what state of matter? Gas, liquid, solid. It's a liquid, excellent. So rain happens in warmer temperatures. It has to be above 0 degrees. 0 degrees is the temperature at which liquids will freeze or they will melt. Okay, remember, 0 is that magic number where that happens, depending on whether you are taking energy out or putting energy in. Okay, the next one is hail, little balls of ice that fall from the sky. Okay, what is the state of matter? Those are solid. They happen in cold temperatures. Now they have to happen below 0 degrees, okay? If it's above 0 degrees, it will melt and turn to liquid. It will turn to rain, okay? Next one, snow. What is snow's state of matter? It's a solid. Happens at 0 degrees as well, below 0 degrees. Sleet. What is sleet? Okay, sleet essentially is falling ice. Okay, hail is also falling ice, but hail are ice balls. Hail is a type of ice that has been going back up in the atmosphere, putting another layer of ice, trying to fall to ground, but then again, the winds will pull it back up, put another layer of ice around it until you've got, it could be as big as a baseball. Like there, it's insane. I don't know, baseball, not a football. Football's too big. Even basketball's too big. But yeah, you can get some pretty good sized ice balls. Okay, hail. So sleet is simply when it doesn't do that, you know, pulling back up in the atmosphere, it just falls the one time. But again, it's falling ice. I mean, when it covers the land, it can make some very slippery, very, very awful conditions. But again, it's solid and it has to happen in cold temperatures below 0 degrees Celsius, okay, when it stays frozen. So evaporation, change of state from what to what? Evaporation is liquid to gas. Okay. Condensation is the opposite of that. Now you're going from a gas to a liquid. Okay. And the last little bit here, clouds regulate the Earth's climate. Clouds are so super important for us. So we are lucky when they are in there. You even notice how much clouds help us in the first question here. They regulate the temperature. Clouds protect the Earth from the sun's radiation. So on a hot, hot day, when the clouds come out and they block the sun, you notice immediately how much cooler that feels, how much great that is. So that's the way in which clouds cool the Earth. Okay, they block the solar radiation. It bounces off the clouds. The clouds are usually white. White doesn't absorb radiation very well. It bounces off of it. Okay. Regulating temperature, it also heats from the sun. Heats from the sun gets trapped in the atmosphere by the clouds. So clouds also work in warming the Earth or keeping the Earth at a manageable temperature. Okay, so not all of the sun's radiation bounces off the clouds. Some of it does go through, and the clouds hold it in so that it keeps the temperature of the Earth at a very good temperature for us to live. It makes it very comfortable for us. And the last thing that clouds do is they release precipitation. Precipitation in the form of rain, snow, hail, or sleet falls from the clouds. Okay, so that last one was a really easy one. But remember that clouds regulate the Earth's climate by cooling, warming, and giving us precipitation. Clouds are really important that way. All right, so I hope you guys have done everything you can to study for my exam. I want to see some good scores. I want to see you guys happy that you got a good score. That always makes me happy too. If you have any questions, I am always around for you to ask. Ask your classmates too. Don't forget, they know this stuff too. Okay, but if you have any questions, feel free to ask me, ask your classmates, and we will get it straightened out. All right, best of luck with the exams, and I'll see you guys later. Let's see if I can figure out how to turn this off now. Oh dear, your poor teacher. All right, thanks guys for listening, and I will see you around, and if you have any questions, please contact me, okay?